Welcome to video 12.3c, the new one. This is a new example this year. Find the surface area of a cylinder with a cutout. So this is example 2, the new example 2. Find the total surface area of the solid. So basically, we've got a cylinder. However, we've drilled through the cylinder in a conical shape. So I don't have an exact solid for this, but we can think of it like this. So pretend like this is the cylinder, and then on the inside we've cut out a cone. Keep in mind, when I'm dealing with total surface area, I'm going to be subtracting that hole on the top, but I'm going to be adding the lateral surface area of the cone on the inside. It's like if I was going to paint this, I would now have an inside surface to paint. So just keep that in mind. What I'm going to do is just break this down surface by surface. Okay, so here we go. Let's start with, I've got a bottom of the cylinder. So I'll say cylinder bottom circle. I've got a plus the cylinder top circle plus the cylinder top circle. I'm going to take away that cone circle minus cone top circle. I've got the going around of the cylinder. So plus the cylinder lateral. And then don't forget I've got on the inside plus the cone lateral. So again, I suggest that when you get to complex problems like this, you break it down surface by surface. It's also easier to get partial credit if you make a mistake in one place, but can show correct work for every place else. All right, so now let me write down the formulas, get the numbers, plug them in, and get an answer. All right. So circle pi r squared, circle pi r squared, circle pi r squared, cylinder lateral, again that's going to be the perimeter, which is 2 pi r times the height, so plus 2 pi r h, and then the cone lateral pi r l. All right, next, let me see if I can get some numbers. So the bottom circle has a radius of 6. So pi 6 squared. Top, same thing, pi 6 squared. That hole that's being subtracted away has a radius of 4. So minus, I want to emphasize minus pi 4 squared plus the cylinder lateral. 2 pi 6 is the radius, 7 is the height, plus the cone lateral, pi, the radius is 4, the lateral. A common mistake would say, students would say, oh, the lateral is 7. Well, just because the number 7 is close to that doesn't mean that's the lateral. The slant. The slant height is the segment that's on the angle. So what I'm going to do is draw a right triangle. This 7 height is the same as this 7 height there. This is the slant height. Okay, I got confused before L with lateral. So that's the slant height. So all I've got to do is find L, plug it in there, and add everything up. All right, I'm going to use the Pythagorean theorem. So just a quick reminder, it's going to be leg squared plus leg squared equals hypotenuse squared. It's very important to know who the legs are, who the hypotenuse is. So you're a leg, you're a leg, you're a hypotenuse. So 4 squared plus 7 squared equals L squared. 16 plus 49 equals L squared. L squared equals 65. Take the square root of each side. L equals the square root of 65. So that's the one number I had to kind of work for. All right, let's see if we can add these all up. So 36 pi plus 36 pi minus 16 pi plus 84 pi plus, not so friendly, 4 radical 65 pi. And again, just to make sure that you don't think pi is under the radical, I'll use parentheses. All right, I would probably deal with these first. So 36 take away 16 is 20. 20, add that, that's 56 pi plus 84 pi plus 4 radical 65 pi. Add 4, get 60. Add 8, so 140 pi plus 4 rad 65 pi. And then what I might do is just totally factor out the pi. So I'll report my answer as 140 plus 4 radical 65, all in parentheses, all times pi. And that would be my total surface area of that solid. So there you have it, how to find the total surface area of a cylinder with a conical cutout.